good?
We're good.
Okay.
So, a couple of items that we saw here that were interesting is this cone splitter, is that what you call it? A cone splitter. And then we have a grapple. And these are, whenever I see something that's of a small form factor, something that might fit a compact tractor, I'm not necessarily subcompact, but because that's not what we specialize in. But when I see something that fits a compact, I'm very much interested in whether or not it'll work on something like we have, or whether they make, some companies make items that might be a little downsized that could work in that. So today I'm talking with?
My name's Mick.
Mick. And we're with Northeast Implement,
yeah.
And we're at the Boonville Woodsman's field days. And there's a couple of items here with this cone and this grapple that just drew my attention. Mick's gonna tell us a little bit about maybe what they take in this format to use.
Yeah, so our splitter cones are typically utilized on mini excavators. Some guys will set them up on a 3-point hitch, or in other situations they'll just get a bit to put on an auger. But essentially what you're doing is you're taking these big ugly stumps and you're drilling down into them until they pop, get them into smaller pieces, more manageable pieces, so that way you can break them down with your splitter.
Mick, I've seen, as have a lot of people, there's commercials on YouTube and whatnot for people selling this bit only in a very small form factor that you can put into an electric drill or a battery-operated Makita or something like that and split small branches and things like that. So there's minimal controlling there with a drill. It's just pressure.
Right.
When you're looking at something like this, what are you talking about the needs might be for a compact or even for the equipment that you purchase?
Well, typically what a lot of guys like them for is just to break down these large yard trees that really are too large for you to kind of manhandle into a splitter without throwing your back out. Other times, some guys, us included, we have a processor that can only take a certain diameter, and when you're buying logs, a lot of times you don't get a choice on the log that you're getting. So if we have a log that's a little too big to fit into a wood processor, we'll use this to break it down into a couple pieces. You can do it in tree length, it takes you a couple stabs, but you break it down so that way you can fit it into the processor. You can still use that product that you bought, as opposed to kind of just throwing it off to the side and letting it rot.
As far as the hydraulics that are required for this unit and the hydraulics that you might think you could get by with and the size of the cone on a compact, where do you think we would be?
So you're definitely going to want high flow hydraulics, and the reason for that is to have some sort of speed on the cone so you're not there all day. The reason though that you need so much hydraulic flow is because these things are geared super low. So they take a lot of fluid to get them any kind of RPMs out of them in order to get any kind of speed. Now, with that comes a lot of torque. You have a whole lot of torque. You got to be careful with that torque because you can get yourself in trouble, be it the log spinning or it putting very bad forces on your machine. But basically, the little ones that you mentioned that you see in a drill, you're going to see that in when you go to get into a knot, and then instead of you being able to hang onto the drill, essentially the drill just starts spinning and wrapping a cord on it.
And take it out of your hands possibly.
So you want to make sure that you're equipped well as far as the sizing of your splitter cone to your machine, just to take those forces and you don't end up with a broken pin, broken boom, what have you.
So with respect to speed, so it's not necessarily the hydraulic throughput that you need or flow rate that you need for the power.
Correct. So your PSI is where you get your power. Typically, a hydraulic cone like this is going to be somewhere around anywhere from 3,000 PSI to the bigger ones. You can get up to 4,400 PSI. But as long as you have the PSI, it'll have all the power in the world. It just won't spin very fast. Where the speed comes into play is just all in your flow.
And what is more important for this to do its job? Is it speed or is it force?
To do its job, it's force. It's PSI. You've got to have the PSI. If you were too underpowered, you're just going to stall the cone. So you're going to start to get into the wood where it really starts to put pressure on all the grain, and it's going to stall the cone. So I think we covered hydraulic power for the most part, but so the cones you can get available without the drive, and essentially they can be adapted to really anything. You can adapt them to an old auger head if you have an auger head for making post holes in the ground.
So really, you would have a template that you need to build a plate for that attaches to the back of the cone.
Correct.
And then you could adapt that however you need to get it down to
Correct.
your auger on the back of your 3-point.
Yes, and a lot of times augers, it's kind of a manufactural industry standard as to the size of the pins that they use, as well as the couplings. No pins as far as adapting, for instance, pinning on an auger, those are usually all the same size. So once you had one of those adapters, or you can make one of those adapters that would bolt to one of these cones, you could use it on an auger, you could use it on a rotator, hydraulic rotator, you could use it on you can even make your own hydraulic little motor setup to run it directly. The only thing is that you have to take the torque into consideration as well as your PSI, because no matter what you're hooking it to, unless it's mechanical powered like a auger, then that's all going to come into play. But mechanical power is kind of a different animal as opposed to hydraulic power.
So let's talk about that a little bit, because when we're talking about adapting a cone to an auger, that power is coming through that PTO of the
Correct.
tractor.
And it's a gearbox.
And it is a gearbox. So what are the demands that might be placed on that kind of a scenario? And is the speed at, what is it, typical 540?
540, yep.
And the horsepower to the 3-point hitch and speed as it relates to maybe what size cone you would even consider putting on there?
Correct. So the PTO speed is going to definitely be higher in aspect as opposed to hydraulics, because typically with hydraulics, the more torque you get, the less speed you get. That's just give and take of hydraulics. PTO, you pretty much know what you have to work with for power, and then you can kind of play with your gearing to change your torque and your speed. Because the same rule of thumb works with mechanical power as well. You go up with power, you go down with speed, or you go up with speed, you go down with power. And you can put this on an auger. Typically, I wouldn't recommend running at 540, probably just above an idle. But as long as you had the horsepower, let's say 18 to 25 horse, and your apparatus was sturdy enough to take the forces that cone is going to put, torque specifically, you should be fine. The only thing that you may run into with mechanical force is that it's a little less forgiving than hydraulics.
I hear you.
So if you were to get into a bad spot, you can kind of get in trouble with it. But
so if we're looking at RPMs, from what you've seen on this driven hydraulically, what is the actual RPM that something like this might spin at?
So on a like an auger setup, or are you talking about? No,
I'm talking about hydraulic. This unit as it sits.
So RPMs, if you have the correct pressure and the right flow rate, typically you're going to get about 40 RPMs so round per minute. So 40 to, I believe, depending on how much torque you got at the time, it gets down to about 20 when you're
That's amazing.
When you're really digging into them.
That's amazing, because we're talking, somebody could take that to 540 and have so much momentum running that thing that it could rip the back end of their tractor.
Correct. It could do a lot of damage if you have too much of a high speed. The problem is it's not nearly, hydraulics are more forgiving because there's pressure relief valves.
Exactly.
There's things in the system that keep bad things from happening.
The only thing that you can prevent that with is with shear.
Correct, a shear pin. You would have to utilize a shear pin.
And mostly they're inclusive in that whole setup.
Yes, usually an auger would incorporate a shear pin.
So what is the maximum speed that you would think that should run at?
Probably around 40 would be the maximum I would recommend. You might be able to get up to 60, but it's going to make your wood pop faster. It'll work a little better that way.
And with respect to, because I'm not aware of the the trade-off, but is there a trade-off in a 3-point PTO-driven implement with respect to speed and horsepower, or the ability to maintain that moving under the backbeat or stress of that log splitting? In other words, when I'm running at 40 RPM, what kind of horsepower do you think I'm getting out of that PTO assembly versus running at 540?
You're going to get less horsepower because your horsepower will arc with the amount of RPMs. That's why a lot of implements are suggested to run at 540, because that's when you get your max arc on the horsepower.
But if you run at 540, you'll rip your shirt.
Right, if you run at 540, bad things happen fast. So what you have to do is take that in consideration when you're using it, especially when you're new at it and using it right off the get-go. It's way better to have your testing done just above an idle, so that way your tractor has enough time to kick in the governor if it needs to get into that power groove, but at the same time you don't stall it. And you can kind of test it, but be ready to hit that clutch in case something goes bad.
Exactly.
Because there's no exact science to these, and there's a lot of math that's involved to really understand and get the correct setup for your horsepower / tractor.
Just out of curiosity, to get a unit like this with the mounting and everything that hangs it properly on the equipment that it's on, what would something like that cost, including hoses and mounting?
Typically, a full setup like this, you're running anywhere from $5 grand to as much as 10. But if you were to do your own system with your own cone, you could save a lot of money. You can save probably somewhere around $3 grand if you were to just utilize a cone and make an adapter. Usually the cones aren't too expensive. They're about $1,200 to $1,500. And the hard part is just adapting it and making it work right out the go, and as well as the hardware that you're hooking it up with being sufficient to hold up to the torque that you're going to see.
With respect to the grapple, simple for a compact is probably the best way to go, simply because it looks like a rotating head is going to give us a lot of requirements for hydraulics and control.
Correct. So if you're using, usually when you're using minis as well as subcompacts, one of your big issues is having hydraulics to run the implements that you want to run. So keeping it simple is always your best bet, because you usually only have one circuit of hydraulics. Ways to get around that is you can look into diverter valves, valves that split the flow from your single circuit to 2 or 3 other circuits, and usually that involves a harness of some kind.
With respect to weight, it doesn't look like these grapples are going to have any issues with respect to being managed by a front-end loader or a backhoe or anything like that. I mean, it looks like maybe 250 pounds.
Correct. And this one actually only weighs 110 pounds, so it's quite light. But what they do to utilize that, to get around that, because what we do is we actually usually try to size the grapple to the machine that we're adapting it to. So we take the machine weight into consideration when we're selling a grapple. But they use high tensile strength steel, for example, hard ox, like you would see on that grapple over there, where it's a high tensile strength steel. It's not likely to crack or break, even though it doesn't have 500 pounds worth of steel in it. It still has a considerable amount of ability.
Right. With respect to adapting that, it looks like it's got an 1.5 inch or something diameter core that you would pin. So in order to use that on, let's say, a front-end loader, how would that possibly be designed, or is there something out there that would go onto a quick attach that would allow that to attach?
Correct. So what they offer is a boom, essentially, and what the boom does is it clips into your quick attach, and it has about a 5-foot boom that comes off with a hanger that allows it to swing left and right, forward and back, and just clip into your quick connects, and then you're good to go.
Now I've seen those quick attach plates that you can buy that attach, and then you can put anything on those quick attach assemblies.
Correct.
That you want. So they use a boom and they have that properly supported.
Correct.
And supported horizontally and vertically on the top and bottom to allow it to take the weight of that and the log, because you're looking at a log that might be 300, 400 pounds.
Correct. Yep. So they're usually they're what's called skeletal frames. So there isn't a lot of steel in them, but the steel in them is heavily built, so that way it'll take the forces that you come across with a with carrying a log or doing scrap or even brush. So all that isn't taken consideration, and usually the biggest issue with hanging a grapple or some sort of implement off the front of something is that you can't see. So they use a skeletal style system to where you can see through it real well when you're trying to grab your material to move it.
In your experience, as far as the cost to both purchase that grapple and to adapt it, I mean, it's only got, like you said, two supply and a return.
Yep.
So you could use your third function if it's on the loader to control it. But in order to get that quick attach adapter and then whatever you need to get into the grapple and the grapple, what do you think a setup like that for a quick attach would run?
On the low end, usually a setup like that, you'd be looking around $3,000. On the high end, if you got all the bells and whistles, as well as like a hydraulic rotator, some manufacturers make a spring rotator, so if you don't have the hydraulics.
Hey, springs back to center.
Springs back to center, yep. You could save some money there. But on the high end, if you wanted everything to move hydraulically, be run with a wire harness right from your cab utilizing your original hydraulics, they can get a little pricey and get up somewhere around $5 or $6 grand.
So let's talk about that. When you're talking about a grapple like the one in the back there that has that hydraulic rotator, how many controls do you need for that? And how would you get that in like a compact tracker that typically doesn't have more than one third function available on the front? I know you can pull cable, you can pull power from the back if you have remotes on the back.
Yeah.
Or like you said, a diverter.
A diverter valve, yes.
So how many controls and how do you think that would be configured?
So how it works is the rotator is going to utilize its own function, so that would be one circuit of hydraulics. The grapple uses its own circuit of hydraulics, so essentially in this case you would need two circuits of hydraulics. If you were to only have one circuit of hydraulics, usually what they use is a diverter valve. They come in mechanical, which mechanical diverter valves are typically $70, fairly cheap, but the issue with that is you have to mount it somewhere where you can access that diverter valve. You're using the same hydraulic valve to charge, let's say, open and close the grapple. You would change the diverter, and then it would now be, for the same function, rotate left and right. The downfall of the diverter valves is that you can't do both at the same time. But
it does take up a little more time to control that.
Right.
Yeah.
So it takes a little more time to run it, but as you get used to it, it'll become second nature. But on the high end, they have electric diverter valves that essentially have a harness or some sort of switch, or basically you can pick your switch. You can go with like a headlight switch where you click it, or you can go with a momentary switch where it only does the function when you're holding that switch. But the issue with a lot of subcompacts, a lot of minis, is that you just don't have the hydraulics to run these, and that's a way to get around that. And how it looks, it basically is just a block with 6 ports, two pressure and return, and then each circuit would have its own set of hoses.
Gotcha. If we're looking down and dirty now, and we have folks that say, look, I could build that interface between the quick attach and that grapple for the standard grapple without any rotation, what would it cost to buy the grapple if they wanted to buy that and then adapt it themselves?
So if they wanted to buy just a grapple, it's going to be fairly cheap for one like this size. It's only $1,200 for the grapple. Like I said, you can try and get into making a grapple yourself as well, but there's a lot of angles there that are a little complicated when you get into them. But as well is it's not plate steel, it's hard ox steel, so that way it's going to hold up well. But usually on the low end it's about $1,200. On the top, high end, if you had a very expensive grapple like this one over here that has lots of steel in it in the tines, about $2,200. So
excellent.
Fairly cheap to start out with, and adapting really isn't rocket science for the most part. It's just pins. It's always preferred to have what's called opposing pins, because if you have pins that are in the same direction, you have a place for your pins to bind when you put pressure on the grapple, and when you bind, you break stuff. So opposing pins are always recommended, and you just run hydraulics to it and you're good to go.
With respect to changing that in the future, if you wanted to, once you have everything set up and you want to add a rotator, then a rotator is just an added implement or an added device, or do you need to change anything in the base design?
No, so if you decided to go with a rotator after the fact of buying the grapple, you can definitely do that. A lot of guys start out with just a grapple, bolting it directly to a plate, be it a front end loader plate or a excavator plate. Once they get a little bit of frustration with not having the hydraulic rotate or any sort of movement, a lot of times they'll buy the rotator afterwards, and it's as simple as bolting out 4 bolts, and the rotator has a pin, and then the toughest part usually is just adapting it to either your plate, your quick attach plate, which may be a half hanger or a full hanger if it happens to fit your setup.
Right. So I'm looking at this, for example. This has that, whatever it is, 2 1/4, 2 1/2, and that has a different adapter on the top of it.
Correct.
So how would that, it doesn't, in other words, they don't make a rotator that is like this on the other side that you could plug right into whatever you use to adapt?
So on the very small models, they don't give you a choice, because the little grapples aren't made to take the stress of the forces that you can put on it if it were rigid mounted. So that way, what they do is they weld a bung onto it where you basically have to put a rotator on it. There's really no choice there. You could adapt to that, but like I said, the grapple's just not built to take those forces, and you may end up with a broken pin or a broken tine. The grapples that are made to take forces are usually available. You can get a dangling mount, or you can get a rigid mount, like this rotator here with the flat top. And you can run the grapple just on a plate by itself, or you can add a rotator to it either way. Usually the rigid mount rotators are a lot more money because the rotator itself has to take those forces.
I gotcha. Makes sense. Yeah. Those are live moving loads, so yeah, you're going to experience the shock of a 300-pound or 400-pound log or more.
Right.
Right?
Right.
Just moving around and swinging it in the air.
Yep.
Exactly.
Yep. So
that's awesome. Listen, this has been extremely interesting for somebody that is interested in building any kind of a system that they can do or use at home in their own processing at either a low-cost level, doing it themselves, or at a higher cost level, albeit more professionally put together and designed by folks like you.
Correct, yeah. And we offer both sides of the market there. Guys that want to do it themselves, we're more than happy to supply them with what they need. But guys that want essentially something that they clip into and start working that day, we offer that too. It just depends on what kind of money you want to throw out there for the most part. So.
Perfect. Thanks so much for spending the time with us today. Very, very interesting. Thanks.
Hey, not a problem.
Very cool. You did perfect. Oh my God.
On the horsepower. Right. If you run that at 540, bad things happen fast.